Okay, Twitch works. Hi, Vibe Huff. Arpit, Okras, hi. For a moment I can put a chat here. Then later when I'm solving problems I will move it on the top of the camera. Because just yesterday it was an issue that sometimes I would cover something meaningful. So I think while talking with chat, this will be best position for the chat, and then while solving problems, it will be like that. We'll see how it goes. Like this seems very chaotic. So for a moment here. Okay. Today, Division 2 problems. Tomorrow, similar time, actually I will put it on Codeforces as well. Tomorrow we will solve harder problems, Division 1, and I think before that it's a good idea to choose the problems a day before. So maybe today in the evening on Discord we will choose, I will ask you to suggest me some good problems to solve for tomorrow. Codeforces, AdCoder, whatever, just something hard. And tomorrow there will be maybe a stream of 2 hours, a little bit more than that, where I solve, let's say the target is 2 problems per stream. Today, just a bunch of easy problems. So what is the most recent thing? Educational around 180. I don't see why won't we just read them in order. Lead code problems? Not today. My plan for lead code is to do some weekend classes, starting from maybe half of July, we'll see, and maybe some streams from time to time, like once every 2 weeks. No lead code today. Should it be thousand in? Maybe this is better. Okay. Let's read the first task. And if it's ugly, I will just skip. Also, this is the link. One more thing I will try to remember in the future. In the title, for people who are joining later, oh, I'm not logged in here. In the title, I'm going to put always a link command, because you can use it if you join during the stream. All good? Polish Olympiad problems seem to be a lot more challenging. I mean, more challenging than Division 2 Codeforces problems, but not more challenging than other Olympiads. Japanese Olympiad is harder, IOI is harder. Okay, when game starts, the price is dropped to a certain point. Whoever gets to it first will get it. Alice will start running at A. Bob has not yet chosen the starting position. The price could drop either at point X or Y. And we want it to be closer than that. Check if Bob can choose an integer point that is guaranteed to get to the price faster, regardless of whether it appears at X or Y. I don't like it. Where's my drawing tablet? Here it is. Oh, and the sound today should be much better. I modified some settings. In particular, it should always be loud enough. I think yesterday it was way worse. On Twitch, okay, the question to Twitch chat. Do you agree that right now the chat that you see on the right hand side is too chaotic with all those copied messages? So I think it's enough if you see it on the screen, right? I think this what you're seeing now on the left hand side, like it's too much copy pasted thing, right? I think what I can do is I can hide this copied stuff. Sound seems fine. Yeah, great. So before I code the solution, I want to reinstall Windows. Do I get the same license? I have no idea, Akshat. Where is chat restream? Sound is good. Great. I've solved C. Well, congrats. Okay, now it should not now it should not be copied. So let's see. Test 1 Twitch, and on YouTube okay, now it on YouTube test 2 YouTube. So you should see those both messages on the screen, maybe with some lag. But there will not be copy pasted. Yeah, I think that works. So you will see messages on the screen, but they will not be copied between the platforms. I think that's less spam. Yep. Good to see you too, Beckers. Okay, let's start problem solving. So the task is Alice is somewhere here. There are 2 points, let's say X and Y. There's X point here, Y point here, and we want to be closer to them. Well, in such a case, where we want to start is here, just after Alice, and then I'm closer to X, closer to Y. On the other hand, if the Y position is here, then we cannot win. Also, we cannot win if either X or Y is at position of A. So my logic will be, if X and Y are on the same side from A, and they are not at A, then I can win and I will be here. Also, this can be on the left side, and that's it. This is what we need to implement. Do we need to just print yes, no? Yes. So we don't need to find the position, just test cases. And read A, X, Y. If both X and Y are to the right of A, then this is good. Or both are to the left of A. I'm using min and max to simplify the code a little bit. I could also type X greater than A and Y greater than A. If so, then print yes, else print no. By the way, you can for sure shorten this code. For example, you can do this into ternary operations, something like print if this, then yes, else no. And you don't want to do it. I understand that this is shorter and this is one line instead of few, but you want to have readable code, because if you make a mistake, you want to minimize your time of debugging. I have not read the variables. Okay, let's run A on input in. Yes, now submit. If the problem was harder and it would take me more time to code, I would just skip it. Maybe I will internally move some windows around. Put this thing here. Chat maybe here to the right. I mean, I would skip it during the stream. Not during the contest, of course not. Will you solve Olympic code anymore? I don't know what is Olympic code. Have I tried Vim before? Only when I was forced to do it. So in my ICPC team, like my teammate used Vim, and when I needed just for a few seconds to modify something there, I needed to use Vim for a few seconds, and it was hard. But at least back then I could exit from Vim. That's something. I don't remember how to do it anymore. Something with :Q? I don't remember. Okay, let's see, next problem. Maybe for those division to streams like the one we have today, I should in advance decide that we are doing, for example, this contest? I don't know. WQ exclamation mark or something, maybe. Yeah. Let's call array beautiful if there are two elements and there exists a position where the two next consecutive elements differ by at most one. Choose two adjacent position, choose something. Okay, ugly problem, I'm skipping. I understand that in competitive programming we care about the quality of a solution mostly, but for easy problems I really hate when it's ugly artificial statement. When I work with students or just to recommend a problem to somebody, I would never recommend something like that, because if you're at a level where this is a challenging problem, then the statement will be, I don't know, disgusting. It will not make you want to solve it. This statement seems nicer. Alice and Bob are playing a game using an integer array of size n. Initially all elements don't have a color. Alice chooses 3 elements and colors them red. Then Bob chooses any element that colors it blue. If it was red, recolor. Alice wins if the sum of red elements is strictly greater than the value of the blue element. Calculate number of ways. Okay, this is fine. So this is a link. And how do I change it for the command? Here. Okay, link command will work. I see, Vibe, that you used segment tree for that. Generally, I don't want spoilers. I mean, after I'm done explaining my solution, so maybe I'm coding, but I already explained what I will do, then you can say how you did it and how you did it differently. Will I be doing lead code streams as well? Maybe. Just from time to time, not as often as Codeforces ones. No problem, Vibe. I stopped wearing specs at the beginning of COVID 4 years ago. I got a LASIK surgery. Okay, I wanted to read the input. No, I want to solve the problem first. We choose 3 elements, color them red, then Bob chooses any element, colors blue. We want the sum of red to be greater than the value of blue. Elements are positive. So I think what will happen is we choose 3 elements. Elements A of I, A of J, A of K. And now I'm solving problem, so let me put this here. Let me know later if this is annoying for some reason. And then Bob, I think, will choose max among them. So our score, let's say that AI is max. Then Bob will choose the maximum of them, so AI. So we want A of J plus A of K minus A of I to be positive. Or instead we can say this. We're looking for triples of elements such that the maximum is smaller than the sum of the other two. I can also write it down. Count triples such that max is smaller than sum of other two. Where I have been all these days, living my life. Please do this more often. I will try to stream more during this summer. I was lucky at this point. I've done a 90% similar problem. Then you were lucky, sure. But you know, solving a lot of problems increases your chance of being lucky. Hi, Ritwik. How do we do this? N is up to 5,000, so we cannot afford to try all triples. If we do all triples, it's n cubic, and 5,000 cubic is too much. Instead, we want to aim at n squared, and I use the Polish word. And usually such problems can be sped up with 2 pointers, or maybe here it will be 3 pointers. So we want to sort the sequence almost for sure, because that's how similar count pairs, count triples problems are solved. So for sure I sort it, and then think about this sequence. When you have 2 elements, let's say that those are the 2 smaller elements, you want the maximum to be smaller than the sum of them. So if I'm looking at here value 5, here value 8, then I want to count how many elements there are to the right, candidates for the maximum, AI, such that it's smaller than 13, the sum of the other two. I can, for example, here use binary search, because the sequence is sorted. I could use also 2 pointers to speed this up, but if we have this, I think it will be fast enough. 5,000 squared is like 20 million, times logarithm, 200 million operations should work fast enough, like 400 million. I think it will be fine. Though if time limit was, let's say, 1 second, I would be worried about it. So let's solve it like this in n squared log, n squared times log of n. We read, sort, and then for every pair of elements, I'm going to binary search on the remaining suffix for the maximum that works. Count k on the right such that a of k is smaller than a of I plus a of j. And actually, for a moment, let's just check if I understand the statement correctly. In half a minute, I can make a sanity check that it works for samples. So let's spend half a minute on that. Let's have a brute force. If a of k is smaller than a of I plus a of j, then answer plus plus, and print the answer. And answer can be long, I think. So now I really spent half a minute and I will get feedback of is the brute force correct. 10 to 16, 4. No, it's not correct. So I messed up something here. And that's good, because if I decided to go immediately for the more complicated solution, I would struggle more debugging it. So let's see. Why do I say 4? Well, because if I choose such 3 elements, Bob will choose one. Bob can choose also something else. Here we go. That's an issue. That wasn't a correct understanding. So, okay. But so you see, this is where I saved possibly several minutes by spending half a minute and finishing the brute force, because in this case, the brute force was just few lines of code. And imagine what time save it would be in a hard problem if I spent half an hour coding something and it would then turn out that I misunderstood the statement partially or I came up with a wrong idea. So Alice chooses 3 elements and then Bob chooses max of them or max in the sequence. One of those two. So let's still say that, so we choose some elements and we want the following to be true. We want a of j plus a of k to be greater than a of I. Also, additionally, a of j plus a of k plus a of I should be smaller than global max. Now, if in my sequence one of those three elements will be the global max, Bob will choose it, so this case needs to be covered, and this is harder to satisfy because Bob will steal the maximum from us. So we don't need to worry, I think, specifically about the case where global maximum is one of those three values. I mean, just we need to focus on that. So I want to here say this, and additionally a of I plus a of j plus a of k is greater than global max, which is a bug because the sequence is sorted. Now let's see if this works on the sample test. I think it works. Yes, it does. So let me maybe simplify this, because we want to get rid of this and we want to replace this with two pointers or binary search. So now I and j are decided, and I'm interested in what k needs to satisfy. And here we have one inequality for k, the other inequality for k. Let me transform this one to simplify it. I will move this to right-hand side. And now I have that a of k needs to be greater than this and smaller than that. Let's simplify this even more. Low is a back minus ai minus this. High is a of I plus a of j. Those were the two values, and now ak needs to be smaller than high and greater than low. I like writing inequalities in this order from left to right. Let's still see if it works for the sample tests. Still works. And now two binary searches are a little bit more time consuming than one. Well, twice more time consuming roughly. But I think we will be fine. Let's see. So I want to do some lower bounds. Lower bound from a begin to a end. No, not from a begin plus j plus 1, because I want to investigate the number of ways to choose the maximum on the right. So on the right from j. ai and aj were two first elements, and then I'm counting good third elements. From this to the end, I want to find something greater than low. So at least low plus 1. Or I can choose upper bound of low. This will find me the first element that is greater than low. Also what I want is first element that is at least high, because this is what I do not want to accept. And then, so this is first good, this is first bad. The difference between them will be my answer. I think we can subtract iterators like this. Nope. I got -1. Maybe. Okay. So search for high. Oh, I only want to do this if low is smaller than high, maybe. I don't want something stupid negative. Okay, now it works. I think. Yeah, it works. Now, you have a choice during a competition to submit this or to test. For example, here, I'm not sure about the runtime. I'm not sure about the constant factor. Can I explain the problem again? I'm finishing it, so just wait for the next problem. Have I done to some problem in LeetCode? Yes, I have, and it's similar. Now, what we can do is either submit or test the speed. And I'm lazy, and this is a stream where I mainly want to talk about solutions. I want to solve problems. In a contest, if I was really unsure, I would use custom invocation here to test how fast this is on Codeforces judging system for a max test. And max test sometimes is hard to find, but here I think a random sequence of values would be okay. But we got less than half a second, so it easily fit in time limit of 2.5 seconds. Okay, so summary of the solution here is that as follows for this problem C that we have just solved, is that you have a sequence, you sort it, and you want to count such triples of values, I, j, k, such that some inequalities are satisfied. You cannot do it in n cubic, you cannot iterate all the triples. And the inequalities, they boil down to something like this. When you already have the two elements I and j, let's say those are 5 and 8, then you want the third value to be smaller than 13. So this third value that you want, it should be smaller than the sum of those two, 5 and 8, so smaller than 13. And also greater than the last element in the sequence, let's say that the last element is 20, minus the sum of those two. In this case, that's 7. That would be a little bit stupid. Let's go with 15? No, 23. Okay. Let's say the last element in the sequence is 23. The story says that our opponent can choose it, and then we don't want that value to be greater than the sum of our three values. But after transforming inequality, we got that the blue element that we now want, it should not only be smaller than 13, but also it should be greater than the greatest element minus the sum of those two. 23 minus 13, that's 10. So in this case, 10. I want to, after iterating two elements 5, 8, I want to here count elements that are in between of values 10 and 13. So here, this will be some range of values that indeed are greater than 10 and smaller than 13. Sorry about my face covering the stuff. And you can do it with binary search. You can binary search this position where values greater than 10 start, and this position where values greater or equal 13 start. If you subtract those two indices, you will get how many possibilities there are. This is n squared multiplied by logarithm from binary search. And there are other solutions too. In particular, you could achieve faster n squared time complexity if you went with 2 pointers. And I'm like 95% sure it's possible. How can I always choose 3 else so that Bob can beat it with max global? Bob can always choose max of those 3. Yes, Bob can choose max of those 3, but also could choose the global maximum instead, and it might turn out better. Okay, problem solved. Let's move on. We skipped B because I thought it's ugly. Reachability and Tree. Let's see. No. I need to later set up OBS some more so I could click a single button and change the layout when needed. One moment. Right, I'm back. Go for E, please. D is easy ad hoc. I mean, I want to read it. The statement is short enough. This is the link. Let U and V be two distinct vertices in a directed graph. Okay, directed. It's good if there is a path from U to V. You're given a tree. Check if it is possible to assign a direction to each edge of this tree so that the number of good pairs is exactly n. Print any way to do it. Well, I want to solve it, I think. Maybe I will not code. Maybe it will only be thinking about a solution. Okay, so given a tree, choose directions of edges so that exactly n pairs would be reachable. Well, n-1 pairs are reachable by default, because for every edge you direct it in one way, so this already gives you something. Right, so for example here, this is already one pair where from 3 you can reach 5. If you direct it the other way, it would be the other way. So what you want to achieve is that only one extra pair is reachable. So there, and here that pair is 3 and 2. From 3 there is a path of 2 up to 2. So I think that the goal is direct 3 edges in such a way that there is exactly one directed path of 3 nodes, 2 edges, and nothing more. And the question is it always possible? I don't know so far. So in a general tree, how do we want to achieve it? If I direct, let's say, everything, almost everything, I want to direct depending on parity. So if this goes down, I don't want those to go down because it would give me a lot of paths. So instead it needs to be like mirrored. So if from the root everything goes down, then from children of children everything goes up, so like this, and from here everything goes like that. So there are layers, like everything here goes down, everything here goes up, everything here goes down. This is by default what we do. And I want exactly one thing to be the other way. And most likely I don't want to change something in the root because that will give me a lot of modifications. Maybe it's enough to change something for a single leaf. If I choose a single leaf, like this one, and I flip it, no, that doesn't work because there can be multiple siblings. So instead, maybe I'm looking for a node that has a small degree. Generally, I'm looking for a node where one edge will go in, one edge will go out, and nothing else. If there is another edge going out, this is already game over because this will not be satisfied. There would be one and second edge. So it seems that I'm looking for a node of degree 2. If such a node exists, we win. And the solution is to run DFS from anywhere, like think about it as the root, and always when you enter a new node, the direction to its neighbors will flip, except for this one special edge where that's not the case, where going out of it, one edge should be out, the other should be in. So one possible implementation, find such a node A and treat this node as the root. From this root, run DFS, but it should have degree 2. It will have 2 neighbors, call them B and C. Give different directions from A to B versus from A to C. One should be in, one should be out. And then DFS should just continue flipping the state always. Yeah, this is why this is one node indeed. I use just a Wacom drawing tablet. It doesn't even have a screen, so it's like a mouse. I think I can code it because it's like, what, 4 minutes? So I will skip a problem either if I don't like the statement or what it is about, or if the code is annoying for some reason. Here, I don't think that's the case. What do we print? Yes, and then print the edges, the directions of edges. I'm looking for the root, and that's something where the degree is equal to 2. If so, then root is equal to I and break. If root is still -1, so I didn't find such an edge, then print no. Don't skip E. Is it such a nice problem or is it a hard problem? Well, actually, don't tell me. I'm not going to skip E. If everyone hates those long-ass story-based problem statements, then why don't problem setters just switch to LeetCode styled problem statements? LeetCode uses more standard problems, and you cannot do that in Codeforces. You will not get enough problems and not enough variety and difficulty of problems. Believe me that it's very hard to create thousands of Codeforces problems, and that's how many there are, such that you would only use short statements. And return, and otherwise run DFS here. There is a parent and there is the direction. For everything among edges going out of A, if it's not equal to the parent from where I came, then run DFS, flipping the direction, and additionally, if direction, then print AB, else print BA. Here, edge is clear, edge is resize n+1. So this DFS will just always flip the directions. And here what I want to do is DFS from the root into its first neighbor, edges of root of 0 with value of false, and to the other neighbor with value of true. Let's say 0 and 1. And that should automatically do everything, I think. Let's see if it doesn't break. I didn't print yes. Now I'm not going to compare my output exactly with this one because there are many possible ones. I think my output is too long. I print stuff multiple times. Everything, almost everything I print twice. Why do I do it? Oh, because this is the other way around. I want to say no. Huh? Why do I print stuff twice? Because only if I'm not looking at the parent I want to print and run DFS. The if was in the wrong place. Because of that I would always print, also when looking back at my parent. Now is this good number of lines? Yes, it is. And in Codeforces you're not penalized with time penalty for wrong answer on first test. So even during a contest I wouldn't check my output. Why did I add int in this if statement? This one, because otherwise I would get a warning with proper compilation flags, and you want to have a lot of proper compilation flags with a lot of warnings. This is different type from here. This is an signed int. This is unsigned int. So if I did this, I would get a warning. I would not get a warning. Why don't I have a warning? C++ warning, different types, signed, unsigned. I want to have that warning. So I'm talking about compilation flags. Maybe it needs pedantic, but I used to compile without pedantic on the previous machine. I never used pedantic, and I many times did that. WAll is here. Strange. Do you get a penalty when you get runtime error? Yes. Compilation error? No. Okay, strange. I mean, I could add a W extra. This is something I did use in the past, so maybe it's that. Let me try. Still no compilation error. So I want 23. Pedantic, though pedantic might give me more warnings. Still not. That's very strange. I will investigate this after the stream. Still, I'm used to doing this, so I will keep doing it. Okay, so recap of problem D before we move on is that we needed to achieve something that boils down to this. We want to direct every edge in a given tree in such a way that there is exactly one directed path of 3 nodes to edges. So almost all the paths, we want to see this shape of one edge going into another edge only once in a tree. And easily you can figure out that if there is a node with big degree, then all the edges need to be directed out, or instead all the edges can be directed in, but not both. It cannot be a mix because you will have a lot of paths of length 2. And there should be one exception. There should be one node of degree exactly 2, where one edge goes in, one goes out. So the solution is find such a node where degree is equal to 2, say that one edge goes out, one goes in, and everything else with DFS continue analyzing edges and do the direction opposite to the previous one. If you went in, then here you want, well, also in, but as you go outside, as you go to the right, you want to direct them to the left. So this one was to the left, so to the parent in a tree, so this one should go to the right. So in DFS, what I did in DFS is I had a current node, I had a parent from where I came, and I had a 0 or 1 value of direction. Do I go to the right, so to the child, or to the parent? And I would always flip it to the opposite value when continuing the DFS. Shall you do streams for upcoming Codeforces contests also? That's a vague question. If you're asking me if like today I will do a stream for the next Division 2 round, then no. But yeah, I will continue doing streams this summer. I have time. Please try streaming more often if possible. I will try. Do you offer coaching for IOI by any chance? Yes, I will soon on Codeforces announce some group classes for summer. So far, the only thing I can suggest is this. So this is what I already set up in the past few days. Here you can, in particular, schedule either a class or a short call with me. Yeah, and soon though I will start group classes, so that's a little bit cheaper per person, obviously. You can look this up. Okay, let's continue. Tree colorings. I wonder if we should even tackle the F problem. We'll see. This is the link. Consider a rooted undirected tree. Each vertex can be colored 3 colors, blue, green, yellow. Coloring is beautiful if it meets these conditions. The root is green. Blue and green vertices are reachable from each other without passing through yellow. Yellow and green are reachable without passing through blue. So this is a connected component, and this is a connected component, where green is like middle part. Blue and yellow, and the root is also green. The tree is rooted. So, oops, you want the root to be green, and some parts connected component, I guess, with the root. That's my guess. And then some outside parts will be yellow, some are blue. Okay. Calculate the minimum number of vertices of a tree of exactly m beautiful colorings. What is the price? 50 euro for a call, so like discussion, 200 euro for a lesson. Okay, full 90 minutes something, mock interview or class. For if you decide to go with weekly classes with me, one-on-one, it's a little bit cheaper. And group classes will be like, I don't know, 30 euro per person per lesson, 40 euro, something like that. W extra is what gives you warning while comparing signed and unsigned. I just checked. Let's check that, but didn't I try to compile with that? So now I don't have the int here. I have W extra in my compilation flag, and it didn't give me a warning. Also, I don't know if double all should already turn on double extra by default. Yeah, strange stuff. Okay, when you read such a statement, you cannot immediately jump to analyzing how to get beautiful colorings. You need to understand the nature of the problem. Maybe there will be some formula that you figure out. Still, I don't even care for now about this part. I want to analyze what this really means. We want to understand this. So let's maybe leave this on the right. Okay, does that work? So green vertices at the top. I want the root to be green, and I think it will be a connected component. I'm not sure though. Then blue and yellow. There can be something blue here, let's say. Edges are not colored, vertices are colored, but well, if I add something green here, and there is at least one yellow, then this is already bad, because green and yellow is not connected without touching blue. So this is what you cannot have. The blues can also be, let's say, here. Yellows can be there. Now, can I do anything more complicated than what we're looking at? So will this be a subtree of green, where connected to it we have subtrees of other colors? Do we need at least one blue, green, and yellow? Because if we don't have anything yellow, then green and blue can be in every configuration. So, well, still the root is green, but this would be okay. Right? I think this is okay. OMG 4 seconds limit. I mean, it's not that important. Like, M is here big. Maybe M instead could be 200,000 and you would have a standard time limit. There isn't a big difference between time limit of 1 second and 4 seconds. If you see 5+ seconds, sometimes it might be a hint that this is a square root time complexity, or they wanted to cut out some logarithm solution. Because of that, they need to increase the limits a lot. Maybe it's an FFT problem, but mostly up to 4 seconds while solving the problem, I don't care about it. You can have all green, all blue, etc. I mean, the root needs to be green. Oh, if you consider all yellow and green vertices, they are reachable from each other. Okay. So I understood it subconsciously as if you have any pair of yellow and green, they need to be reachable without going through blue. Okay, you're right, guys. This doesn't work. So it's only this. Subtree of green and connected to it this stuff. Calculate the minimum number of vertices in a tree with exactly m beautiful colorings. So what I want to do is like figure out the shape of a tree such that number of ways to color is something. So we are given a tree. I'm giving a white tree. Not given. I need to consider it. So I'm given a tree. And now the task is everything by default touching the root will be green. And starting from some points, I think it will be very important to consider such cut points. There should be some cut points where I decide everything below has a different color and one of the two colors. So I can choose some edges in this tree, as long as they are not with vertical orientation to each other. I cannot choose this edge and this edge. And for every such edge, I have two possibilities of deciding the color of stuff below. So it's almost, but not exactly, the sum over value k of number of edges that will change a color of n-1 choose k multiplied by 2 at power k. I'm saying almost, this would make sense because among n-1 edges in a tree you choose k of them. For each of them you choose if the color of subtree below will be blue or yellow. That being said, you don't want two edges such that one is below the other, like it's subtree of the other. You cannot for both of them decide to cut it and to change color of stuff below. Why does earlier idea not work? The tree that I erased doesn't work because it actually doesn't satisfy this condition if you think about it. Check announcement. In the explanation of yeah, sure. Why didn't they make drawings? What also might be important is that we're not investigating arbitrary tree. We want to find the optimal tree, and because of that only some shapes maybe we want to consider. So this doesn't work because it doesn't understand that edges can be above each other. But that being said, this would work for a star. if the tree was a star, so just one root and children of it, this would work. If maybe size of the tree will be small. If size of a tree is no, this is not an easy problem. So let me explain why I dropped an idea. Stupid idea is I wanted to say maybe n turns out small. N is the optimal number of vertices, and I thought for a moment maybe the number of colorings grows exponentially, and because of that small n is enough, like up to 50, and because of that I can do different things. That would be stupid, because every m needs to result with different n. What? No. Oh no, that's not true, because it's different shapes. Okay, never mind. Maybe it's not a stupid idea. So maybe, even though m is big, up to 500,000, n is very small. Just trees of size up to 20 should be considered. Still, there are a lot of them. Where is the windscreen with formulas? It's there, behind that wardrobe thing. There. I don't know if I will want to take it out for every stream. I will see. Okay. Given a tree, I'm sure I could do it with some kind of DP that goes bottom up, and it counts number of ways to choose different edges or nodes to cut so that they would be like next to each other. It's it would be, I think, DP of node by count, and in the subtree of this node, how many ways there are to cut that many edges, so that we would only cut, cousins, not ancestor descendant. But we don't have a tree. If m was up to maybe 10,000, I could try all possible shapes of a tree up to some size, like up to size maybe 10 or whatever, and then for each of them count the answer. But I cannot possibly, I don't think I will be able to consider enough trees to hit all the values from 1 to 500,000. Maybe for some reason we will need to look at binary representation of m. Because here we hit something exponential, in particular it's a power of 2. Should I be able to solve this problem by now? How quickly did people solve it? 10 minutes. 10 minutes. 15 minutes. Okay, I should be able to solve it in a few more minutes. Well, if you look at a subtree, you can say that it has some number of colorings and it's basically independent from others. Maybe it's one big DP problem. Maybe there will be FFT involved. Can there be FFT here? Not sure. So if the root is green, what are possibilities for children? Either this child is also green, it has some subtree size here, and it's basically the same problem as originally, so whatever the number of nodes here, you can read it from DP. Or instead, a child can be already yellow, and then everything here is yellow, only the shape matters. Oh, then, I mean, no matter the number of nodes here, the number of ways to color will be 1. So if you have like X nodes here, then number of ways to color this child of the root is 1 plus dp of X, where this is number of ways to color it, assuming that this node itself is green. So this will be the answer for that subtree, plus 1, because this also can be just full yellow or fully blue. So actually 2, not 1. So this will be multiplied by something, like number of things for other children. Oh, and wait, now I said something at the beginning maybe about factorization or product. If you have you want to achieve M as the product of such values. In particular, those values will be at least 3. You want to express M as the product of values, each of them at least 3. And what do you have as the very basic thing? Or what if this is a prime or something like that? If it cannot be expressed as a product. So if, for example, you want to achieve M equals 7, I think it means that the root needs to have exactly 1 child, and its dp of X needs to be exactly 5. So let's say that M is 7, then you have the root, and you want to here create something with answer of 5. 5 also is a prime, so it seems that okay, you have this, and you now need to here create something with answer of 3. So 3 is also a prime. So we have this. But wait, won't we get an 8 here? What is the answer for 7? For 7 the answer is 4. They didn't explain. I feel that I'm on the right track. I want to do a brain scan while Richter is solving problems and see how many neurons are firing. That would be interesting. You be hitting gym lately? How many pull-ups can you do in a row? No, I don't go to the gym, but I play a lot of volleyball. For the past year, I go to volleyball twice a week, sometimes 3 times. If the number of trees with only green and blue is X, and then for green and yellow it's also X. No. If something is... let me try to reply to this message. Regarding this message, I don't separately count. I don't actually count trees with green and blue and trees with green and yellow. When I look at my child, when I have the root and I look at its child, I have a possibility that it's green, the child itself, and then below there will be whatever. It's like a recursive sub-problem of the same thing, where I count trees that have green, blue, and yellow. So that's dp of X. And the other possibility is that this child is yellow, and then below I cannot have another green. Everything is yellow, 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 yellow. That's one possibility. Remember that we consider that a tree is given. It's not given, but we need to find such a tree. So there is one possibility for yellow, and there is one possibility for blue. So this is 1 plus 1 plus this. This means child is yellow and everything below is yellow. Child is blue, everything below is blue. And this means child is green, everything below is green, blue, and yellow. So actually, it's not that we ever here count something that is only green and blue. That doesn't happen. Though, reasonable question. This is why I'm answering. And what did I do? What did I click? Okay, what's dp of 1? Dp of 1 is, well, you can only have green. What's dp of 2? You have green, 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 blue, green, yellow. So we should get a 3. Okay, that works. All right. Now, regarding factorization, I wonder if we should do it greedily or we should do it more like dp. So if I have some value like m is equal to 40, should I consider all the different factorizations of it into values that are at least 3? Because 40 can be 4 times 10, also can be 4 times, or maybe 8 times 5. I don't feel like I can say which version is better, so I think we need to recursively find all possibilities. I don't think there can be many of them, but it's very hard to say. I would need to just test it for a reasonably big value with a lot of factors. So I feel like we will have a recursive solution that will try to break m into products of values at least 3. And for each of them, we will run recursively to see how big the tree size can be. So dp of 3 should be 5. Wait, what is this exactly? What am I writing? I'm saying that for tree of size 2, the number of ways is 3. Shouldn't I say the other thing? Shouldn't I say for number of ways equal to 3, the best possibility is 2 nodes? I think that's the order I want to go with. So I want to define dp of m defined as minimum number of nodes. So that's the actual answer. And when you want to compute it, you try breaking m into different values. For example, if m is 40, then one possibility is that it's 8 times 5. You know that m you should represent as this, and you say then dp of m you want to minimize with the possibility that you have the root, which is 1, plus dp of 8 minus 2 plus dp of 5 minus 2. The meaning of this is the following. I want to have a subtree with 8 ways to do it, but I have 2 ways that are basic. So I want, okay, maybe this. Okay, ways. Okay, I want this to be 40. I want 40 ways. There is a possibility I can represent 40 as, for example, 8 times 5. So maybe this is 8 and this is 5. So this is 6 and this is 3. I want a tree. I want smallest possible tree such that it will give me 6 ways. Hence this. So I represent M as the product of some values, not necessarily primes. Every AI is greater or equal 3. And then dp of M you want to minimize with 1 plus dp of A1 minus 2 times dp of A2 minus 2 and so on. I think that's the solution. What did I write here? dp of 3 is 2? What? Oh, I didn't fix this. This meant, I mean, it's not easy to figure out, but there is a tree with 3 nodes such that this. And dp of 4 is also possible. No, it's not possible. No, it's not possible. But dp of 9 will be. And I think dp of 9 happens to be 3 nodes. Because it's this shape. So 9 is 3 times 3. 3 is possible this way. No, it's this. So 5. Well, let's see what program tells me. I think that this is correct. But it's very easy to mess up the order of thinking here. Like it's in particular unusual that the dimension of dp is number of ways. dp of 9 is 3. Okay, so wait. I confused myself. dp of 9 is achievable like that. Will my program correctly see it? M will be represented as 3 times 3. Oh, and we read not dp of 3, we read dp of 1. So this times this. And this is plus, not product. It's number of nodes needed to achieve this, number of nodes needed to achieve that. Okay. A bigger example for a moment. Let's say M is equal to 1000. In particular, I can represent this as 4 times 25 times 10. Okay, that's one of many ways. So I say that what I can create is I can try to create such a tree that it has 3 children. There will be small subtree here, bigger one here, and even bigger one here. And I want them to have, I want this one to have 2 ways, 23 ways, and 8 ways. To be colored such that the this one is green. I want 8 ways that this is green and this is whatever. And I recursively ask for a number of nodes needed to achieve that. Why 8 and not 10? Because there is also a way that this is everything yellow, this is everything blue. 2 extra ways. If I see that, oh, it's possible, not green. It's possible to use, let's say, 5 nodes, 1, 2, 3, 4, 5. It's possible to use 5 nodes to achieve 8 ways. Then I will say, okay, 5 nodes needed here, plus, let's say, 10 nodes needed here, plus, let's say, 1 node needed here, plus the root itself. So that's 1 plus 1 plus 10 plus 5, that would be 17. 17 is a possible answer, the number of nodes to achieve result of 1000 ways. No, I'm not connecting tree to another. There is a root and there are its children that are independent from each other. It's not that children, so the subtree is made from children, they are independent. So if this one, for this one I need you know, if this one gives me 50 possibilities to color and this one gives me 20 possibilities to color, then 50 times 20,000 possibilities to color. And if this one requires 5 nodes, this one 6 nodes, then in total that's 11 nodes. Nodes I add up, ways I multiply. So what was the most important thing? This. I'm going to copy this. There are many test cases, so we need to solve for every m. To be honest, I didn't think about it too much while solving the problem, but okay. Let's also define dp. dp of m define as minimum number of nodes to achieve m ways. Okay, and because it's minimum by default, it will be infinity. I saw a question in the chat. It will not be -1. It's easier to use infinity when you minimize. So there are test cases. I'm going to just in main. For a moment, forget about test cases. We'll take care of this later. We have this is the max. Can I do this? Okay, dp of 1 is 1. Okay, and for every greater m, you try to split it into the product. Why did I remove what I copied from OneNote? This will be, by the way, the last problem I'm solving today. Stream on common proving techniques used in solving Codeforces problems. Common proving techniques. This would be more of a math / logical stream. I'm not sure. So it would be, I think it would need to be a lecture that I prepare for a lot. The idea of those streams that I do every few days is that I just solve problems. Maybe it's a good idea for a lecture one day. And stream on constructive problems, I think we can make such a topic stream one day. I'll think about it. Next week, as I posted in Codeforces, next week, few days I will not stream because I'm out of Warsaw. Maybe then, while out of Warsaw, I will think about it. Can I say that dp of smaller m already considered this? Interesting. I think that I don't need to actually split into all the recursively into all possibilities of how this splits. I will just say that iterate the first divisor, and then this already some other value of m considered, and dp of this smaller m was its own value of this. Already it includes a +1, so I don't need to add it, and I just need to add this. dp of 2 is unreachable, right? I cannot do anything with it. Also, then what I will do is just read if dp of m is infinity, change it to -1, print it. Okay. For a moment, slow quadratic version. Iterate the first divisor. If m modulo a is 0, then dp of m minimize with dp of a minus 2, add to dp of m divided by a. That's like how the rest works. In particular, this can be 1, and if so, it will be just 1 plus this, which is correct. Okay, let's decrease the maximum so it would work in time. So recursive function wasn't needed. Why so slow? Oh, I thought that I'm changing this to 5000. One, two, three, four, three. That's good. -1, that's good. Okay, so just what's needed is if you want to iterate all divisors, then you should do it by iterating multiples, actually. Just like in primesive. And now it's n log n. That being said, I find it strange that the time limit is so big. Maybe it's because of another solution. Sorry to comment about specs at the beginning of the stream. No problem. I mean, it's not a surgery to save my life. It was my choice to get it done. So it's not something that you need to be sorry about. No problem. Oh, change max, of course. Thank you. Thanks to Loxa Gamer. Usually during the streams, I don't want help solving the problem. I want help debugging, because debugging is boring and annoying to observe for you. May you stream on persistent bits, dynamic segment tree? To be considered. The smaller x, as in this, don't have the same factors as m. Zikrus, I want to consider different representations of m as the product of this, where every AI is represented as 2 plus x. But so because of that, the values here should be greater or equal 3. Still, this needs to be a divisor of m, but actually when I see that this is divisor of m, what I will look up is this value minus 2. I don't know if that answers your question. Can you summarize your solution once, please? Cheating. Yeah, that's, I mean, getting help with debugging is cheating. I agree. Still, I don't know why the time limit. Okay, summarize the solution. Though the problem is quite abstract, so if you don't know the statement yet, you will not be able in 1 minute to figure it out and understand the solution. Okay, so, and this is the last thing we're doing today. So problem E, summary. We are given the target number of ways m. We want to find the smallest tree such that exactly m colorings with m colorings, and I will define colorings in a moment, and output only the number, the mean number of nodes, n. M is the input value, m is up to 500,000. Now for the number of colorings, we want to find such a tree that if you consider it, you analyze number of possibilities to color it green, blue and yellow, so that green would be the root and some connected component of it, like next to it, let's say, and then out of it they grow blue and yellow subtrees. For example, this can be yellow, maybe this is yellow, and then this is blue. You cannot mix blue and yellow in the same subtree. In other words, it's some green shape and growing out of it blue and yellow subtrees. Inside of blue subtree there cannot be something yellow or green. You count the number of such colorings. And now if you want, so that's the task. And we can observe that if you have the root, which needs to be color green, that was the requirement, and it has, let's say, 3 children, or any number of children. For every child, it of course has some big subtree below. There is a subtree. Either this child is yellow, and then everything below needs to be yellow. So that's one possibility. Or this child is blue, and everything below is blue. That's one possibility. Or finally, this child can be green, and then the number of ways to color this is equal to dp of size of this subtree, because it's the same as the original problem. So plus dp of x, where x is number of nodes in this subtree. This is the total number of nodes to color the subtree. The 1 plus 1 comes from the fact that for this child of the root, we don't require it to be green. It can be yellow or blue, and then everything below is defined in one way. This is number of ways to color the subtree, and then you have some number of ways to color the second subtree, the third subtree, the fourth subtree. So you have the product of such values. If the first subtree size was x, second is y, and so on, then you will have this. Let's simplify it to 2 plus dp of x. You multiply it by 2 plus dp of y, and so on. So m, the target number of ways, is equal to this. You have target number of ways, and it is equal to those things. What is dp of x here? It's number of ways to color a tree with x nodes. But I want to minimize, so actually I don't know this, and I cannot afford to iterate always how many nodes will be in such a subtree. So instead I think, what will be this value? Let's say that m in particular can be represented as 40 times 70 times something. I consider factorizations of m. So if one of divisors of m is 40, I say, okay, maybe I want such x, such number of nodes, such that this value is 38. That's my divisor of m minus 2. If there is such x, such number of nodes, that there exists a tree with answer equal to 38, the number of ways equal to 38, then that's good, because that gives me 40 here multiplied by some stuff, it will give me m ways. But I want to know how many nodes are needed for this. So I want to know, if I want 38 ways for tree of some size, I want to know that minimum x size is equal to, for example, maybe 15. Maybe there is a tree with 15 nodes. Let me hide the camera. There is a tree with 15 nodes with exactly 38 ways. This is very important for me. Given the number, I want to know minimum number of nodes. So actually, in my code, I used different kind of dp. Not dp of nodes is equal to ways. I didn't use that. I instead used dp, call this dp2, of ways is equal to nodes. That's quite unusual, but knowing the number of ways I want to achieve, I want to know minimum number of nodes. For example, here it would be dp of 38 is equal to 15. When I read m from the input, I want to just print dp of m, right? I'm given number of ways, I want to print how many nodes are needed. And now how do I compute this dp? For every m, I consider its possible divisors. If I know that m is equal to a1 times a2, a3, for example, then I say dp of m is equal to minimum of itself, comma, dp of a1 minus 2 plus dp of something and so on. Why minus 2? I explained it here. Why do we add? Because this is number of nodes in the first subtree, this is number of nodes in the second subtree, number of nodes in the third subtree, and so on. Plus 1, because you also have the root dp of this. This is number of nodes in the first subtree, so subtree of the first child of the root. Number of nodes in subtree of the second child of the root. And this is the root itself. You cannot afford, in terms of time complexity, to try all factorizations of m, but you can only iterate the first divisor, and you can do it prime-sieve style, by iterating multiples actually. And instead of immediately factorizing this, it is just some kind of smaller m prime that you already consider different factorizations of. So you just say, you wonder what this should be, you iterate the divisor a1, and then this plus that's just dp of m prime. So let's, this is dp of m prime. And we can then once again take a look at what the code said for that. The code, of course, eventually it is just a few lines of code, so very simple, but coming up with it wasn't necessarily trivial. Here we prime-sieve style, we iterate first the divisor, so that's a is basically number of ways to solve, to color the subtree of the first child of the root. And this is the multiple, the value m, so that for that a would be a divisor. And then I look at dp of a minus 2. Like if I want 40 ways for this first subtree, then I want it, if we consider that the root is green, I want it to have 38 ways. Plus one way that all is blue, plus one way that all is yellow. And dp of, this is what I called m prime a moment ago. M divided by a is the remaining number that I want to factorize. And dp of that already tells me. So this actually, this highlighted part, it hides inside the 1 plus dp of a2 minus 2 plus dp of a3 minus 2 and so on. This instead can be replaced with iterating the sequence of other divisors and using that. Time complexity m log m, because it's like prime-sieve. Will dp of m divided by a be computed correctly? I think what I used here without explaining is the fact that every m can be considered in order of decreasing in order of increasing factors. So m maybe can be represented as 50 times 20 times 15 times 40, but in particular it can be represented, let's say, like this. I mean, one of the ways, I think. So what do I want to claim here? I claim this. When I get to value a equal to 50, those values were already considered. So dp of this highlighted m is computed correctly using values smaller than 50. So now when a is 50 and I consider this m that is product of all of this, dp of m divided by a will be computed correctly using those things. So here, let's say invariant, every dp of m is computed correctly using divisors from 3 to a minus 1. Something like this. By the way, Gupta, very good question. And it would be perfectly possible that this is some huge issue causing the code to be completely wrong. So good that you asked. I actually did not think about it, at least not for more than half a second, where I maybe subconsciously said, maybe it will be fine. And square root of n solutions? Oh, maybe, I'm not sure. Let's take a look at the editorial. Stack at candidate master, what to do? Just like stack at every other level. No, practice properly. Solve problems that are challenging for you. Yes, you need to, indeed, Gupta, think about the largest one. So we always, in this factorization, what we basically iterate is the biggest divisor to be used, which doesn't necessarily mean the biggest subtree size, but there is correlation. What does the editorial say? Oh, the solution in m square root. Okay, so that was allowed. I could do it like that. Interesting how short the final code was. While solving the problem, I thought that it will be more complicated to code. Do you live stream on YouTube every day? No, far from it. I will live stream tomorrow and maybe in 2 days, and then I will have few days of a gap. Okay, few things. Now, I don't remember if we have command for calendar or something like that. Calendar schedule. Oh, I have this here. Does it work? Oh, it works. Okay, I will now post some stuff. This is a calendar that you can import if you want. But also on Codeforces, maybe a day before, I will try to do it a day before I post the schedule of my stream, and there is a countdown. On YouTube, I don't know, maybe I will also create events, but that's more work. But once you add up a few things that each of them takes 2 minutes, you eventually have something very annoying. It's where it's easy to miss something, and because of that I might just eventually sooner than later decide to again give up streaming for a few months, because I don't want to bother setting up stuff for 20 minutes. That's just really annoying compared to solving problems, where solving problems is fun. There is also this blog I made where you can look it up with just schedule for the next few days. And finally, if you want to book a call with me, here's another link. I need to make all of this into commands. I also should maybe put some text at the bottom of my screen, like here at the bottom of the screen. From time to time there will be some message, like advertisement of stuff. Okay, so are we good? Should I do anything else? What should I study to understand time complexity of this? Should I... So Adam Vinovich, regarding your question, what should I study? Basically, if you study prime sieve of Eratosthenes, you will in particular see there the time complexity chapter, and it explains why it's n log n. What I used here today is the same. So let's say, make sure you understand that algorithm. Don't give up streaming. I will try. But for that, I for sure, I want to keep the stream setup to be simple, so that in at most 10 minutes I could start streaming. That's, let's say, my limit. And I will actually stream more often and for more months if I keep it simple. Okay. Oh, I know what I want to ask everybody. So today, was there much spam today in the comments? I didn't read everything, but I think it was fine, right? I remember from the previous year that often somebody, especially on YouTube, somebody would often repeat the same question and it would be very unrelated to the stream. I think it was fine. Did you find it annoying that the chat messages were on the screen as well? And was it a good strategy that when I'm solving a problem, the messages are here, and then when I'm talking and the right hand side of the screen is black, then they can be here as well? Is that a good strategy? I know some questions were repeated. It's very hard to avoid that, but I think it wasn't that bad today. Oh, Ankit, good point. Select problems for next on Discord. Okay. By the way, on Twitch you have Discord command. Favorite Linux distro? I keep using Ubuntu, but I don't really use others, so should I be able to compare and recommend? Okay, general. I've opened the Discord server. Where do we want that to happen? Suggestion. I don't want it in general. Anybody using our Discord server, what is the proper channel for this? I want to ask you, not a single person. I want to get suggestions for Division 1 problems for tomorrow. Something hard, difficulty 3000 or so, I think. There is, Gupta, a reason why I don't full screen editor after reading the problem. There are people who join, and having this on the screen helps a lot. In particular, including this. I understand that they can hit a command to get the link, but not everybody uses the chat. There is a huge difference between this and doing something on the right versus full screening, because if you join the stream and you see this, you have no idea what is happening. Maybe what I could additionally do is on the top of my camera, I could display some, like here, the text information, what we're solving. But I think that it's very valuable for people who are joining in the middle to see this. Also because they can look it up. They can even search for Codeforces tree colorings, and they will be fine even without a link. Swapping left, right. I'm too much used to this, but I will consider. How can I start doing Codeforces? Respect. I have a YouTube video about that. If you search for Erichto YouTube how to start Codeforces, you will find my video exactly about that. Okay. I will just use general for now. I need suggestions for good recent Division 1 problems to solve tomorrow stream. Okay. So that's it. Tomorrow the stream will be when? It will be 12 o'clock Polish time. So 1 hour later than today. You will see countdown on Codeforces. Thank you everybody for joining, for the suggestions, questions, and so on. I hope you enjoyed the stream. I would say put it in the announcements. General, we move ahead easily. Yeah, Gupta, but I want to also collect the ideas. And I can announce in announcements, but how should you guys post your suggestions? So not sure. We'll see what happens. Now I need to go. Bye everybody.